we're going to talk a little bit about systems of linear inequalities. And you know how in Chapter 11, when we first started solving systems, I told you that the solution to any system is the point or the ordered triplet, the ordered pair or the ordered triplet, where the systems where the lines or planes intersect. Well, when you talk about inequalities, if you'll remember, when you solve an equation, you get something like x is equal to 2. Whereas if you solve an inequality and you get x is less than 2, your answers look very different because x equals 2, you don't have a choice. It's 2, and there's nothing else you can do about it. But if you get something like x is less than 2, it can be any number less than 2, all the way to negative infinity. And so if you remember from Math 100 or your basic algebra class, when we actually did a solution for an inequality, we did coloring, right? So you'd put the number on the number line and then you'd color in the direction that the inequality was representing. Well, when we talk about linear inequalities, same thing. In Chapter 7 of Math 100, when we graph these lines, when we graph the linear, not equations, but inequalities, you remember you graphed a line, but then you had to shade either the top or the bottom part of it because you had a bunch of solutions. Well, same thing here. When you solve a system of linear inequalities, I know in Chapter 11 I told you do not graph these. And the reason being, I showed you why, because you can't pick out fractional answers. But with an inequality, the best way is to graph them. Okay? And so that's what we're going to do. To graph or to solve systems of linear inequalities. To find the solution of a system of linear inequalities, you must use the graphing method because the solution, again, is a shaded region. Okay, it's not just a point, and it's not just a plane, an ordered triplet or ordered pair, but it is a region. And when we start doing these systems, it's kind of fun, actually. So you're going to have a whole bunch of different areas, and you have to figure out which area you're going to shade. So step number 1, you are going to graph each of your linear inequalities just like we did in Chapter 7. So if you need to review, look back in Chapter 7. I think it's maybe the last section of Chapter 7. Linear inequalities, anyway. So you're going to graph all of the linear inequalities on the same graph. Oh, 7.3. There you go. You need to review that. It's in 7.3. And then what you're going to do is you're going to shade the region that makes your system true. So you're going to pick test points. Okay? So, look at this. First of all, we have to remember how to graph a linear equation. And you have two options, and I showed you this at the beginning of Chapter 11. You can either use slope-intercept form or you can use intercepts. And if you know how to use both of them interchangeably, it's going to make your life so much easier. And I gave you one like this. For example, the first one, I would graph this one by using intercepts, simply because it's in standard form. So to graph the first equation or inequality by intercepts, first of all, let's talk about, are we going to use a dashed line or a solid line? Let's see who remembers. For the first one, is it going to be a dashed line or is it a solid line? It is dashed. Reason being is because you don't see equal to. So the ordered pairs on the line will make the left side equal to the right side, and that's not possible. It has to be greater than. And then the one on the bottom, you do see that it can be equal to, and so this one's going to be solid. So do you remember that? Okay. You might want to get you some color pencils for this, just so you can see what's going on. But anyway, so for the first one, to graph this, to graph x plus 3y greater than 9. Again, I am going to use the intercepts because it is in standard form. So your x-intercept, look, if I take out the y, because I'm not interested in the y is going to be 0, and so your x is going to be 9. And so you have an ordered pair at 9, 0. Well, if I wanted to find the y-intercept, I'm going to take out the x, which means x is 0. And I would solve for y, and I'm going to get y is equal to 3. And so your y-intercept is going to be a point on the y-axis. And we said that this line was dashed, so what you're going to do is you're going to draw a dashed line. Alright, so that's your top line. And then how do you remember, hopefully you remember, from Chapter 7 and from Math 100 or from your basic algebra class, how do you decide which side am I going to color? Because the line itself is not the solution. That is not, because it's dashed, so that is not the solution. Either this top side is your solution or the bottom side. Yeah, you pick a point. I always use 0, 0. If your line doesn't go through 0, 0, use 0, 0. So to test just the first one, I'm going to use 0 plus 3 times 0 greater than 9, so you get 0 greater than 9. True or false? That's false. So since this ordered pair will not work, none of them on that side will work. So what I'm going to have to do is I'm going to have to color in this side. Now you have to understand that I've only done one line. I've only done one line. So now let's go to the other line. For this one, I think it would be easier to do it in slope-intercept form. So we have 4x minus y less than or equal to 5. You can put equal to, it doesn't matter. Minus 4x from both sides. And so you'll have negative y is equal to negative 4x plus 5. Change all your signs, and so you'll have y is equal to 4x minus 5. And the reason I say just do equals to is because when you divide by a negative, you know that you have to change the sign around. We're not worried about that right now. Okay? So, slope-intercept form, we're going to graph negative 5 on the y-axis, so we're here. And then we'll use our slope. We'll rise 1, 2, 3, 4, and run 1. And we can do this all day long. 1, 2, 3, 4, 1. And so this line goes up through here. Now, you understand that we have 4 possibilities. Okay? 1, 2, 3, 4. But when we graphed that first one, we ruled out these bottom 2. Right? These bottom 2 are not possibilities simply because we had to color above the line. So now let's see which side we're going to have to color with the red line. You can go back up to your original, or you can just plug it into the one that we just solved for. Again, I'm going to use, I can't use 0, 0, right? 0, 0 is not a solution. Do you understand why?
It's on the side ends. 0 is not on.
Right. 0, 0 is right here, and when we plugged it in here, it came out as a false solution. Therefore, 0, 0 is not a possibility. Can you tell me an ordered pair that would be a possibility? One that I've already colored.
4, 5.
4, 5. That's a good one. So let's try 4, 5 right here. So we're going to try that one. So if I try the ordered pair 4, 5, I'm going to plug 5 in for y. Not equal to. We're using our original. Let's just go over here so it'll be less confusing. So again, 4, 5 is going to be our ordered pair. So we'll have 4 times 4 minus 5 less than or equal to 5. So we'll have 16 minus 5 less than or equal to 5. And so we have 11 less than or equal to 5. True or false? That's false. So since this one didn't work, we have to color on this side. And do you see where they overlap? Where they overlap, that is your solution region. So this is your solution. And that's what I'm saying. If you want to use colored pencils, you can. But the green is your solution. So what is the other option? Your other option would be to do this. Your other option would be to get both your lines on here and pick a test point out of all 4 of your regions until you find one that works for both lines. So that's your other option. However you do it, completely over your choice. Okay? Questions? Are y'all awake? Hope so. All right, before say 2 by 2. So let's look at this. Now we have 4 inequalities. Do you see that? You have 4 inequalities, and it's not as overwhelming as it seems, I promise. Look at this. For the first one, I'm going to have a solid, and make sure you know this, solid dash solid. Does everybody understand that? That comes off of your inequality. If there's a line underneath your inequality, it's solid, meaning the points can be equal to. If there's not a line, it's dashed, meaning the points cannot be equal to. It's that simple. Just look at your inequality. Now, this is the tricky part. X greater than or equal to 0. What kind of line do you think that would be? Let me make it easier for you. If I asked you to graph something that said X is equal to 3, what would you tell me? They're all straight, so you can't say straight line.
It'd just be a line going for 3 and going straight equal to 3 on the y-axis.
What variable do you see? You see X, so it has to go through the X-axis. So what kind of line would that be? It's going to be a line going through the X-axis at 3. It can't be horizontal. You've already told me that it has to go through the X-axis at 3, right? Well, if you draw it horizontal, it's going through the X-axis at every point. That's not possible. It can't go through the X-axis at every point. It can only go through the X-axis at 3. So that's going to be a vertical line. Okay, so now that we've had that discussion, X greater than or equal to 0. What kind of line is that going to be, horizontal or vertical? Vertical. Anytime you see X equals, it's always going to be vertical. If you see X equals, it's going to be a vertical line. It's going to be a vertical line going through the X-axis at 0. So that's that line. It has to go through the X-axis at 0 only. It has to go through the X-axis at 0 only. So if you draw it horizontal, it's not going through the X-axis just at 0. It's going through the X-axis at every single point, and that's not possible. Okay? Now, y greater than or equal to 0. If I ask you to graph a line that said y equals 3, that one's going to be horizontal going through the y-axis at 3. It can only touch the y-axis at 3. Okay? So what do you think about ours? Y greater than or equal to 0. It's going to be horizontal and it can only touch the y-axis at 0. Okay, so let's start putting this together. For the first one, you can only have X values greater than 0. You can only have X values greater than 0. So that's going to be this way, right? So this line here, you would color these. The next one says y has to be greater than or equal to 0, which means it's all of those, right? You take the y-axis and it's all of your numbers greater than 0. So what quadrant are we talking about? You're talking about quadrant 1. So your solution can only be in quadrant 1. So those two boys, Jake, move. So those two inequalities right there cut your solution options in 4. Not in half, but in 4. Because it has to be in quadrant 1. You don't have a choice. It has to be in quadrant 1. Okay? So now, let's do the other two lines. The 4x plus 3y is less than 12. 4x plus 3y is less than 12. What is your x-intercept going to be? What? 3. Your x-intercept is going to be 3. What is your y-intercept going to be? 4. Good job. And this one we said had to be dashed, right? Okay, Okay, so now, look at this. I need you to wrap your brain around this, okay? Once we put this one in there, watch this. Now our solution either is going to be this little triangle or this right here. Remember, it can only be in quadrant 1, so it's either going to be this little triangle or this right here. All right? So let's throw the other one in there. If we do x plus 5y less than or equal to 15, what's your x-intercept? Your x-intercept is going to be 15, and that's not even on my graph, so we'll just put it way out here somewhere. What about your y-intercept? It's going to be 3. So look how fun this can be. It's going to be solid. Now what have I done? Well, your solution region can be this triangle, or this polygon actually, this polygon, or this polygon. So even though by putting those first two inequalities up there, it bounded me into the first quadrant, by adding those last two lines, it opened it back up. Okay? So your solution still has to be in quadrant 1, but you have 1, 2, 3, 4 possibilities. 4 possibilities. All right, so let's think about this. Let's look at this one. First of all, let's pick a point. 4. I heard 4, 1 first. 4, 1. 4, 1. So we're going to try the test point 4, 1. And remember, I'll make it red. It has to be true. We know it's true for the first two, right? It has to be true for the last two. Has to be true for the last two. So let's try it in the 4x plus 3y is less than 12. So if we do 4 times 4 plus 3 times 1 has to be less than 12. Well, we get 16 plus 3. So it's not a solution. So we know that's not a possibility. Pick another point. 1, 1. Okay, let's try 1, 1. Do you understand that we just wiped out this whole polygon? It's not an option anymore because it was false. When we plugged it in, it came out to be a false statement. Do you understand that? Okay, so let's go here and let's try 1, 1. Well, if we plug it into the first one, we're going to get 4 plus 3 less than 12, which is going to be 7 less than 12. True? All right, let's try the bottom one. So we'll have 1 plus 5 times 1 less than or equal to 15. So we'll get 6 less than or equal to 15. True? There's your answer. So your solution is this polygon right here. How cool is that? I love it. Love it, love it, love it. All right. Again, you do have a Chapter 12 test next week. You will see the linear inequalities on that test. Do you want to try one that has 4 on it before we take our test? Okay, let's try one of those again.